directions. So what do we expect to see here? If it deflects in both directions.
Torsion.
What kind of rings? Because first we saw this elliptic. What do we expect to see here?
Curvature. Curvature of the corners.
Do you agree that you should have rings here? Because it's dispersing to the rings. Let's have a look at this here. If you stand from above, you can actually see the rings in the corners.
Van het midden komen ook ringen.
And it deforms downwards. Can you see?
I also see rings coming from the middle part. Is that right?
Yeah.
Yeah.
Some rings are like from.
Now look, if you look here, you can see that actually the outer edge deflects more than the middle. Well, in the computer you saw that the middle deflects more than the outer. The reason for that is that this is made of rubber and has a high Poisson's ratio of half. And because the Poisson's ratio is high, it gives this anticlastic curvature. But we had to look for material that was flexible because it needs to curve in both directions. And it needed to be heavy, otherwise you don't see anything. So the only material we could find was rubber. Because if you use steel or some other...
You couldn't see anything.
And it's too stiff. What?
Je 6 gebruikt.
No. I used my mind. Because I knew rubber had a low emulsive elasticity, so it deflects easily. So we found this rubber shop in The Hague, and it also has to be white, otherwise you don't see the lines. Now this is how they used to calculate, because in the old days they had another double curved mirror, and they could project another image and another one, and then they made photos, and each time you shift them out of phase, it's like you take a derivative. And if you could have those photos and shift them 4 times, or actually twice, you get the curvature.
Shift what? Like degrees?
Yeah. So if you shift the 2 Moiré patterns,
Like shift it like 30 degrees or 45 or something?
yeah, you get a derivative. So they could make...
So is 45 the highest derivative? Or
no, you have to
90?
do it twice. So they make 2 photos, and then they shift them, and then you get a picture for the curvatures. And that's how they used to calculate the bending moments in these, before they had the computers. But now it's just
point and click.
point and click. But it's still very insightful, I think. And you can also do some fun, because if you now, for example, change it. Now the fun part of it is that if you can very quickly see what the consequence of a design decision is. Now you have the support over here, so it's this large cantilever, and you see a lot of deflection going on. So by just moving these supports around, you can easily determine the best combination to upgrade. Any questions? Yes. So as you can see here, each line, if you do it in this configuration, each line is a deflection of 1 millimeter. So if you have more lines, you have more deflection. So actually you could count the number of lines, and if it's very flat, you have less lines, and the more lines you get, the more it deforms. better on the computer.
So they really did that? They really overlaid? That's like really, that's really,
We used to have.
I mean, it was probably convincing back then, but
Actually,
to imagine someone.
It's actually quite accurate if you compare it with. I have the old.
But how long ago? Like,
Yeah,
like
in
18th
60s.
century? Oh, really?
So 40
Really?
years ago, yeah.
Oh my god.
I still have the book, and because my old professor used to make these calculations, and if you compare them with computer calculations, they're actually even more accurate than computer calculations.
So why are we doing this?
More accurate?
Yeah.
How is that possible?
There's no abstraction.
Because a computer is an approximation, and this is the real physical
But
model.
could you get a material that to simulate?
Yeah, they used the Perspex because it has the same Poisson's ratio as concrete. And it was.
And they just do like a scale model?
Yeah, and they had it was black Perspex because you had nice, but the reflections were very good.
Wow, that's
And they made these photos.
kind of frightening.
But this mirror was this big, and it was this huge double curved mirror.
And that was really a method.